Um, as I mentioned, I've been working in the ML space for about 8 years now. I started as a developer, building anti-abuse systems for Microsoft, and then transitioned to program management in anti-spam, again at Microsoft. After that, led a bunch of teams, helped build startup teams in ML at Sears Home Services, Smartsheet, and currently at Evernote, where again I'm building a team that's focusing on building apps, ML-based applications. So just to give you a little overview of what I'm going to be talking about today. So I'm going to start talking about like ML in general, what the opportunities are and what the challenges it presents for product managers, especially what the ML solution development process looks like, and most importantly, what are the opportunities for product managers to make a big impact in what might seem like a mostly technical area, right? That's run by data scientists and developers. In general, machine learning is the field of study in which we teach machines how to learn without them being explicitly programmed. So there is, you can think of declarative programming or symbolic AI even, where there's a bunch of handcrafted rules that you input into a computer, and then you input some data and the computer spits out answers, which is traditional classical programming. How machine learning is different is, you don't input the rules. The rules are actually output by the system. What you input is data, and answers, which we traditionally call labels in machine learning space. Obviously, this is, in supervised machine learning, there are areas like unsupervised machine learning, reinforcement learning and stuff where you don't explicitly have labels, where the computer infers labels as well. But traditionally machine learning, you provided data, you provided answers, so which is basically a labeled data set, and then it generates the model for you, which is what we can simplify as rules. And again, in machine learning, sorry, it doesn't show up too well here against the light background, but that's fine. Basically, depending on who you talk to, there's a couple of terms that get thrown around a lot these days with regards to, what is AI, what is machine learning, and deep learning. They tend to get used interchangeably, but these are very specific terms, where AI is a superset of, machine learning, where you would include symbolic programming, where you're building expert systems and handcrafted rules. Machine learning is what I was talking about, where you don't provide the rules, you let the computer infer them. And then there's deep learning, which is a subset of machine learning, which is basically where you have models that have multiple layers that that requires a whole lot more data than traditional machine learning would. And there's a funny anecdote about that I've seen float around, like, AI is mostly a marketing term that you use when you're talking to investors and shareholders. Machine learning is what you say when you're trying to hire people, and then it's logistic regression when you're actually building something. Yeah, so like, why are people interested in machine learning? So basically, it's commonly referred to as the fourth industrial revolution, right? Where it's going to completely transform a lot of the industries that we know today. Good examples would be transportation with autonomous vehicles that often get referenced, retail industry, personalization. Nowadays, everybody uses it, including brick and mortar retailers. And medicine, it's not really been transformed as yet, but the hope is over the next couple of years, we'll start seeing a lot of applied machine learning, especially form like the first layer before you get to a doctor, that allows you to do diagnosis. And today, one of the case studies that I'm going to talk about is going to heavily leverage like the healthcare industry. And a lot of industries, like in 2019, IDC estimated about $36 billion are going to be spent on this application of machine learning across different industries. And nowadays, a lot of companies think of it as a defensive play, right? How do you battle a lot of the big players like Google and Amazon, who are getting into a lot of the different areas, including retail as well as healthcare and other industries, traditional companies really need to invest in machine learning in order to be able to defend their turf from. And it also represents a huge opportunity for product managers to make an impact. 8 out of 10, like I said, a lot of industries, a lot of companies are starting to invest in machine learning, but 8 out of 10 projects that start when companies start investing in machine learning, 8 out of the 10 projects fail, mostly because of the lack of data, lack of good data. But there's a bunch of different issues that can cause failure, and one of them can be lack of iterative development, where product managers can help a lot, and also with the data acquisition piece of it. So what do I mean when I say human-centered machine learning, right? So machine learning, with any software development and product management in software, there's a bunch of key considerations that you need to have. When you talk about machine learning, there is some unique aspects to projects that leverage it, that you also need to be aware of as a product manager in order to successfully build and deploy ML solutions. And especially when it comes to product managers, you're not just thinking about the data and the model generation, the model selection, and hyperparameter tuning. You're thinking about how it actually gets used, right? What is it that your end user sees? And for that, you need a lot of, you need to invest a lot in the product thinking in order to make sure that you're building the right solution for the right users. So this is not unique to machine learning solutions, but when you're thinking about building any sort of software application, you first need to think about what your user needs are, right? When talking about machine learning, often the mistake companies and teams make is, you take a very solution-centric view, like how can I apply machine learning to solve this problem, rather than, okay, what are the user needs? What is the actual problem that needs to be solved? And machine learning is just a tool that you can employ to solve that problem. But that's also probably one of the most expensive tools that you would employ to solve a problem. What you need to start thinking about first is, are there simple things that you can do in order to get the solution to where you want it to be, right? Like, are there simple UX improvements that you can make first? Are there heuristics that you can build? And by heuristics, I mean like those, handcrafted rules that can help you solve the problem or help you build a model that can, at least serve as a baseline that you can later on think of investing in machine learning to help improve. And then before you start thinking about, making a major investment in, like building a data science team and acquiring your own data and building data pipeline and stuff of that sort, you should also think about, can ML as a service help here, right? Because a lot of, if you're talking about image recognition, if you're talking about, natural language processing and natural language understanding, there's a lot of tools that are available to you that, Amazon, Google, anybody who builds, infrastructure as a service is already investing in, that can help you, just leverage the models themselves rather than having to acquire data and build the model yourself. So first think about the user needs and think about like what are the cheap ways in which you can help build the solution without making a major investment in machine learning. Then when you've decided that yes, ML is the only way we can solve this, you also need to think about the user experience, right? Because ML is non-deterministic, unlike any other thing that you make. So you need to think about, what is the expected accuracy of the system for it to be effective in this space. As you can imagine, like if you are building something for healthcare, for diagnosis, for detecting cancer, for example, your accuracy requirements are way more than, like a personalization system for retail, right? If you're building a recommender system for retail. So you need to think about, are errors acceptable at all, right? If you say that, if the answer comes back saying like, okay, there's zero room for error in this, ML is probably not the right solution for you, right? Then you need to think about, again, like I said, the impact of the errors, right? If it's going to, completely ruin the user experience, every error that you make, let's say you're building a chatbot and, if your chatbot's not able to understand what the user is saying you go into a unrecoverable failure state, then that's not a great user experience. So think about whether you have enough data to build a good enough system that would be able to withstand some errors that you make. And then there's also constraints around understandability, right? Like you might use a machine learning system, you might build an ML system that's fairly accurate in terms of the predictions it makes. But if the user isn't able to understand what is being recommended and why, or it freaks the user out that that you have this data and you're able to with great accuracy make these kind of estimates, then that's something that might kill your system. Like there was this very famous case study with Target a bunch of years ago where they, based on your shopping patterns, they were able to detect if somebody was pregnant or not, and they sent out these flyers that completely freaked people out. And so then they started, interspersing random ads along with, very targeted ads. So those are things about, where understandability might be a bad thing, and then you can think about Netflix, right? Where initially they started giving out recommendations based on your viewing history, but they found that people weren't adopting those recommendations as much because they didn't understand okay, why is this thing being recommended to me? I don't recognize any of the stars. This is not traditionally something that I watch. So then they started providing those banners based on, okay, because you watched this movie, now we are recommending these movies, and they saw a big increase in uptake of those recommendations because now users understand why these recommendations are being made. And very interesting related to that is this entire field of explainable AI, which if you are thinking about building AI solutions for enterprises where there is high stakes, let's say for sales like lead scoring and stuff of that sort, people need to know why are they seeing these recommendations, right? Why is lead X being scored above lead Y? They won't adopt these recommendations unless they understand. Same for healthcare, right? If you're talking about a system that second guesses a radiologist in terms of is this cancer or not, they need to understand how this system works and why these recommendations are being made to me before I can think of even adopting them. So the next is the data availability for, like I showed in the previous slide, 8 out of the 10 experiments in AI fail because there's not enough data. So you need to start thinking about, okay, do I have enough labeled data to be able to build an effective machine learning solution here? If the answer comes back as no, or you need to acquire this data, then that's the first problem you need to solve before you can even think of investing in machine learning.
Excuse me.
Sure.
What does XAI stand for?
Explainable artificial intelligence. Yeah. So it should be E, but for some reason the common acronym they use for that is XAI. And yeah, guys, feel free to interrupt me at any time. This is meant to be more of a conversation rather than a talk. Yeah. So basically, can you source label data? Is the label data the data that you're getting representative of the population that you're going to apply your system's going to work with, and is the data unbiased? Like we've seen a lot of cases with the Google image classification where they made some very, very public and embarrassing mistakes with labeling a certain population of people as gorillas and stuff, which was extremely embarrassing. So you need to think about can you source good representative data, and then the privacy and governance around this data. I think this, again, when you talk about human-centered AI, I think this is a very key and very undervalued aspect of ML applications, where people think about how can I maximize the amount of data that I have, collect data that I don't really need right now, and not think about what the privacy implications of that might be, what a security breach can cause, what kind of damage that can do, and also if governance around that data, like who has access to this data, what can they do with the data. Recently there was a case with Amazon where an employee or an ex-employee made available a bunch of really a bunch of private data about its users and also about the companies that were storing data in AWS. Like those, as you can imagine, are extremely expensive mistakes to make. So you need to think about like, what is the data that you really need? How are you going to make it anonymous, anonymize it, and also how are you going to control access to it? And all of that requires major investments. And then when building a machine learning solution, one of the key things to consider is, the V1 that you ship or the MVP that you ship is not going to be highly accurate, and it's not going to, get you there. You need to think about, making iterative investments, and how do you build the system iteratively, where first, if the accuracy of your model is not great, like how do you mask that and actually be able to get more data and learn incrementally and improve your model incrementally. So you need to think about, the UX that you built and, the investments that you make. Like how do you iteratively get more data and get better at that? And then, failing forward is in the first few versions of the system that you build. Think about, what not only like what the ultimate goal is in terms of the user experience that you want to drive, but also what my learning goals are. Like what are some of the questions that I need answered from V1, from the MVP in order to build an effective V1. And that's in general true about any system, but it's especially true about machine learning because you're also acquiring data and proving out the initial models that you put out there. And in terms of general rules of thumbs of when you use machine learning, it's basically when there's lots of data that you can't possibly, all sift through and, build heuristics yourself. The data patterns change dynamic, like anti-spam is a great example of that, where you have billions of emails flowing in through your, inbound servers every day, and every time you detect spam and stop spam, the spammers are incentivized to adopt their systems to, get through your spam filters. So you can't, build just handcrafted rules and expect that they work for a long period of time. And when you're building personalized experiences for millions of users, obviously, machine learning is a great candidate for those kind of applications. So in terms of the process of developing an ML system, I don't know if some of you might have seen this before. It's a very it's about a 20-year-old model that was developed by IBM and Teradata and others. It's called the CRISP-DM. Stands for Cross-Industry Standard Process for Data Mining. This is generally the approach for any machine learning project. I mean, obviously, it's a little bit oversimplified. You can think of, there's loops that exist at various places in this. But in terms of, generally how you get started, you start with understanding the business, understanding the needs, then understanding the data, sourcing the data, and understanding, what the data actually means. Then you go into the data preparation and modeling phase. You go into evaluation and eventually deployment, right? So this is actually the realm of data scientists. This is or ML engineers, and this is mostly the realm of, your traditional software development, where, you're taking a system and deploying it into production, where over the web or whatever mechanism it gets consumed, scaling it out and making sure that it runs over time. Okay. So before we start going into depth on each of those phases of the development process, I just want to kind of provide a case study that we can use to kind of think through some of the problems and challenges that we're going to be talking about. So this closely parallels a system that I built on one of the companies that I worked with previously, but it's in a different domain. I obviously can't talk about that. There's a lot of proprietary information that I might divulge as part of that. So I've built kind of a parallel use case or a problem that's related to the healthcare industry. So let's say the problem that we are trying to solve here is there's a healthcare system like Kaiser Permanente, for example, that runs hospitals, that runs primary care clinics, urgent care clinics. And the problem that they have is there's a lot of false ER trips, right? Where people come in to the ER for things that are not emergencies, and they don't understand that these are not emergencies. So the goal of the healthcare system is, there's a huge cost associated with that in terms of, having staffing capacity, overtime pay, and, just morale and retention of the staff if, your ER is always overwhelmed with the number of people coming in. So the goal of the healthcare system is to reduce these emergencies, right? Reduce ER visits for things that are not really emergencies. What they gain from that is they'll have better patient outcomes, higher patient satisfaction, and obviously lower costs. And the patient's goal is, obviously I don't want to go wait in an ER for 4 hours for something that was not an emergency that could have easily been taken care of by me myself as, over-the-counter drug or something that I could take, or, just wait a little longer and it would go away. And I would obviously save a lot of money by not making that ER trip, especially if I'm paying out of pocket for some of this. And even with co-insurance, this can be pretty expensive. So for the case of this, I want you to suspend disbelief for a little while and assume there's no HIPAA considerations or, major liabilities associated with building an ML solution that predicts whether this is a real emergency or not. Right. So going to the first phase of the ML process, like the business understanding, what we want to do is, get a very crisp definition of what the problem is that we want to solve for our users, right? And this is a product management one-on-one, right? Where you're thinking about the product market fit. Like what is the solution that what is the problem that you're looking to solve? Who is the customer? And then how is the solution that you're proposing going to solve that problem? So for our use case, the customer, let's say, based on the data that we have demographic information of, when all of these false emergencies happened, who the customers were. Let's say they were mostly millennials or first-time parents, right, that came in with these false emergencies. Their need is to actually determine whether or not this is an emergency, right? But does it stop there? Like, if your ML system was able to tell them that this is not an emergency, like that wouldn't be very valuable for the user, right? What their ultimate goal is to get a solution for it. If it's not an emergency, okay, what's my next best action, right? Like, what do I need to do in order to, resolve this issue? Do I need a over-the-counter drug? Do I need to see a primary care physician? Like, what exactly is my next action that I need to take? So when you think about defining the solution, like from the healthcare system's perspective, the solution is just, maybe a system that predicts based on symptoms and the customer, what we know about the user, whether or not this is an emergency. But for it to be actually effective from a user point of view, you need to know what the solution is. So then you need to define what the success criteria is. And MTMM stands for a metric that matters most, right? Like, how do I tell if a system that I'm building or thinking about building is actually successful? In this case, in the healthcare diagnosis case, it could be, the percentage of false ER visits should go down over time, right? And we can set a target to it, like, based on the amount that we are going to invest, let's say by 20%. Like, we need to, any system to be successful needs to cut down the number of false ER visits by 20%. And then need to define the user experience. This is, again, the definition that the product manager needs to do is, understand the business problem, understand the customer problem, and define the right solution, right? So define the user experience that you want to have, right? How do we map, what goes into the MVP and what's in the V1? Like, how do we get around the problem of, right now we don't have a lot of data, or we have data that we can do training on, but we need to really validate this system before we can, with confidence, tell a user not to come to the ER, right? So that would be, in the VP, maybe MVP, you'd shadow deploy that, or when a person comes into the ER, you just collect the data and make a prediction that you don't actually do anything with, and then see how well your system actually works in making these predictions. And then defining the constraints as well is something that you need to do when you define the solution that you're building. Is okay, the system needs to be interpretable or understandable, so that the user knows exactly why the system said, like, don't go into the ER. So with that said, taking a first pass at defining the solution, right? We've identified what the user problem is. So we can think about this as the user tasks that need to be done in order for this this solution to be successful. Right? So the task that this needs to support is first triage. Think about diagnosing whether this is the first level is whether this is an emergency or not. But then, like, what is the actual problem, right? What is the actual solution for it? So in those terms, you can think about various levels of the solution, right? So the size of the box actually represents the cost of building that. So if your solution was to provide just a common set of symptoms and remedies that users could select from, that would be relatively cheap, right? You're a healthcare system, you have a ton of data about the symptoms that users present, some mostly in natural language, and what solutions, what cures they track to. So you would think of building that first. Then you would think of a natural language search system where a patient inputs their symptoms, and based on that you could provide, like a Google search, you could provide a few solutions that are ranked in the order of relevance based on the patient history and the symptoms that they presented. And then you can think of natural language dialogue as the next step, where like you incrementally learn more about the patient and the problems that they are having, and then get them to like the one right or the two right most probable cures for the symptom that they're seeing. And the way we decide, because one of the things that we said is, the definition of the problem is such, like, you don't have emergency visits every day, right? And also, when we said our target users were millennials and new parents, we can think of, maybe the best channel to provide this solution through would be something like a Facebook Messenger chatbot, where, it's very capable in terms of, you have a lot of control over the experience, but it's also not an app that somebody's not going to go and install for, the once in a blue moon emergency that they have, right? So that's something that's among the, as you narrow down the possibilities of how you want to surface this to the users, you could think of, okay, as a healthcare system, I have certain users that I can message and send this chatbot out to. I don't need to really install something. They just need to connect with us and get the right solution for us. Then the second step of the process might be, okay, I triaged and I found out that it's not a real emergency, but now, I didn't get the right solution. What would be the next step for this solution to be actually effective, to get me to an end-to-end, to provide an end-to-end solution to this problem, right? Maybe the next stage would be consult an expert, like a nurse helpline or something of that sort. Could I build that into the solution as well? Right, so you can think about text chatting with a human in the loop as something that you could invest in, or you could do offline diagnosis with pictures and videos. Like, okay, my eye is getting really red. I need to know if this is, an emergency, or just if this is an infection, or just, a wound that will heal over time. Right, like you can send a picture and have somebody diagnose that. Or you could think about a live audio video chat with an expert, maybe a physician's assistant or a nurse who could at least get deeper into the diagnosis phase. And the third phase would be, okay, like none of these solutions actually work, none of these steps actually work for me. I can go and schedule an appointment or find a doctor or specialist through the chatbot. And in the first phase, if you decided, or if the system said, like, okay, this seems like you're bleeding out, this seems like a real emergency, then what your solution would provide is, link to the nearest ER, or, even a request an ambulance feature. Right. So then when we start building this solution, the first step is the data acquisition, right? Without the data, we're not going to be able to do any machine learning whatsoever. Right? So you can think about, when you're thinking about acquiring data, you can think of, there's different considerations there. Is like, how will you source the data? Like, how will you label that data if it's not already labeled? Then what are the privacy and governance considerations around that? Like, what are the standards you need to think about and consider before you can even build the solution or use any of this data? And then how do you build the feedback loop? So in terms of sources, sources can be internal or external. In this case, we are saying we are a healthcare system, so we rely on internal sources, right? We've seen, we have a lot of patients that come to our hospital or healthcare service, and they give us data, they give us patient history, and we know what the ultimate outcome was, what the remedy was. So we can start there. And in some cases, you'll have like a cold start problem where you have nothing, like you can't buy the data from somewhere else. You don't have any data, like you're brand new startup trying to build this new cool machine learning app. Then you need to think about like, okay, how do I build a UX to get this data, or think about unsupervised learning techniques where you don't require as much labeled data, but obviously your error rate is going to be really high while you're learning and getting your system up to effectiveness. And then label data. If your source data is not already labeled, in our case it is, you need to think about like, how do I get labels on this data? Like, can I use something like Amazon Mechanical Turk, right? Crowdsource users, recruit users to label data sets for you, and think about like, speech recognition. The way they initially started is there are a bunch of audio clips that you send out, and then you have a human that goes and listens to them and actually transcribes these for you, and that's how, that's forming a label training set and also your test set. Then there might be internal content experts. In our case, as we are a healthcare system, we have content experts that actually went in and labeled that, okay, this was the cure for, these were the symptoms presented, this was the patient history, and this was what the solution was for that patient. So you are leveraging internal content experts in that case to get that. And again, with recruiting users, there's two aspects. There could be unpaid, and there could be paid users like Mechanical Turk, Cloudflower. A bunch of services exist in that space. The privacy and governance, this is obviously extremely important when you're talking about collecting new data and having new use cases for that data. Is there are standards that govern what you can collect and what you can't collect, and these are very, in the US especially, these are very different when you talk of enterprise versus consumer space, right? In consumer, it's still a little open-ended where you can collect data. You need to think about securing the data, but not about the aspects of what you're collecting and stuff. In healthcare, obviously, there's things like HIPAA that govern what data you can store and save and who can access that data. In enterprises, in most enterprise use cases I've worked with, like it's a non-starter if you say that you're going to use sometimes get data from company X to train a model that could be leveraged by company Y, right? So you need to think about rewriting your privacy, or thinking about, how do I build a model that only works for company X? Like, will I even be able to get enough data about company X to build an effective model there? And then encryption, audit trails, that all comes into the aspect of governance. GDPR is obviously, if you're building any service that's going to be used in Europe, you need to have those, the ability to roll back, to delete data, to make sure that you can provide audit trails for who touched this data and how the data is used. And then there's a lot of really interesting work happening in privacy conscious ML, like federated learning and differential privacy, which is something that Apple uses a lot in that the data is anonymized from the get-go, right? Like, you can't associate data that you're using for training with any specific user. It's obfuscated so that you don't have to worry as much about okay, what if this data leaks, or who has access to this data? So thinking about those aspects is super important and valuable. And then about the feedback loop, right? So you might not have perfect data to start with, or you might think you have perfect data to start with, but once you deploy something in and put it into the wild, you'll realize that, okay, my model efficacy is nowhere near what it showed on the training data, like variance is way higher than the bias was. And so you need to think about instrumenting your UI in order to get feedback from the user on whether or not something was actually accurate. And so you need to ask the user, and you can even have surveys and stuff on the user themselves, telling you like, okay, did this work for you or not? Then this is again, I would say, so the data acquisition, the product manager plays a very important role in. When it comes to data understanding, I think this is more a collaboration between the product managers and the data scientists, where the data scientists are experimenting constantly with the data, and they are telling you whether the data is efficacious or not. And in most cases, you might have to work with partner teams that you're sourcing data from, or the actual, stakeholders who you're getting data from. Like, in this case, in the healthcare system, it would be actually you have to work with, the front end, like the reception or whatever, like the guys who create the people who create the forms that intake patient history and intake, the symptoms, or transcribe the symptoms that feed into the system itself to make sure that they are hitting the accuracy mark. So you need to, as a product manager, you need to understand upstream systems where the data is collected. As kind of an expert on the business, you can also help the data scientists who might be new or not as familiar with the specific domain, help them identify the right features that they can start with as the candidate feature set to build the heuristics or to feed into the V1 of the model that they start experimenting with it. And then visualize and validate the inputs. This is also extremely important when you're talking about like virgin data sets, right, that have never been used for anything, so you have no idea if they are accurate or not. And so this is more of a collaboration again with the data scientists, between the data scientists and the product managers, and in some cases the engineering teams themselves. Then we come to data preparation, modeling, and evaluation. Again, this is something that, this is actually extremely heavily reliant on the data scientists to do. This talks about data preparation, like about feature selection, where product managers might have some input, and based on their domain knowledge or knowledge of the business, they might be able to help with this. But the cleanup and the feature engineering is mostly up to the data scientists to do. And then like picking the right model architecture, hyperparameter tuning, this is squarely in the domain of data science. And then evaluating and setting the precision recall. The important role that a product manager plays here is initially when we went to the metric that matters most, what a product manager that's especially conversant in ML would be able to do is take those metrics and actually map them to model accuracy and set goals for your AUC or your precision recall that a data scientist can go and work against, right? This is extremely valuable for them so that they know like when to stop and when to keep going. Or even like if they know that, okay, based on the data that I've churned through, I can only get to like, let's say, 50% AUC, AUC of 0.5, and your target is 0.9, then they can tell you right from the outset, like, this is not worth investing in. The data isn't clean, or we don't have enough data to ever get to this point. So you can cut your loss and move on. But there's also some cautions, especially for data science, for product managers who have a background in machine learning or data science. Like you don't want to be this guy who when a data scientist tells you my productivity plunges every time you learn new jargon, right? Like for example, reinforcement learning. Like I've had cases where like a manager or a high-level executive comes in like, hey, have you Google or Facebook is doing great things with reinforcement learning. Have you tried this for our use case? And then data scientists have to spin through some cycles to just provide data of why reinforcement learning won't work for us. Create checkpoints and measure progress. This is extremely important, especially when there are stakeholders. If you're doing this in your organization for the first time, and it's mostly been an engineering-driven organization, stakeholders don't understand the uncertainty associated with data science, right? That these are all experiments and there's no guarantee of success. So in that case, as a product manager, it behooves you to kind of set those checkpoints and show progress and translate what AUC and what all the progress that data scientists are making to the business teams or the stakeholders that make the decision of proceeding with that investment or not. And then knowing when to pivot. This is extremely important. And yeah, a key value that product manager adds here is communication. Communicating not just with the data scientists, but with the stakeholders, so that they are able to understand what some of the challenges are, where we stand, and what any specific metric that comes from data science means in terms of the effectiveness of the overall system and where we be able to get it. And the last phase is deployment. This is extremely heavy in terms of the engineering investment needed. But going back to my first point, like if you can get away without having your own training set and building your own models, try and do that, because getting training data and then deploying a system is extremely resource intensive and expensive, and there's a lot of considerations here. I would recommend this paper highly for anybody who's interested in it, the Hidden Tech Debt in ML Systems. It talks about all your upstream dependencies, how your data, once you deploy something in production, how the patterns of data might shift, and what you need to keep an eye out to make sure that the system that you thought was accurate initially is still good enough to deploy. It's just mind-boggling how much you need to take into consideration when you deploy an ML pipeline. One of the things that I've found extremely valuable to do is the sensitivity analysis. Like once you see a model is good enough to deploy in production, you want to do sensitivity analysis on the input feature set. Because if there's features that are not adding a ton of value, you want to consider taking those out, because over time you'll see a shift in terms of all the features that you're getting and using. Like one example from my career was we were building this anti-spam system for Hotmail, and one of the clients, the mobile client that we were dependent on to get the system off from the signal from the user that something was spam, just deprioritized within the UX where that flag, something as spam button, was located, and that completely changed how much data we were getting on spam. And like this, the models that we were retraining now were starting to get less effective, and we didn't understand for a while why that was, until we figured out that there was this change in the client, and now less users are flagging things as spam. They're just going and deleting stuff or unsubscribing from it. And again, like in terms of lean product development, right? Build iteratively, design for the long term, but actually just build for your MVP. And extremely important, prioritize the feedback loop. Right. So going back to our use case, so based on what we built, like we found okay, without investing a lot in ML, we could get increase our resolution by 20% by just building that. That used ML in terms of and a lot of data analysis in terms of selecting which symptoms to surface and the remedies that are associated with it. But without having the natural language dialogue agent, we could get part way to our goal. So the next phase of investment would then be the natural language search in the knowledge base, rather than having to jump directly to the natural language dialogue. And then also opens up new possibilities in terms of personalizing the diagnosis rather than investing very heavily in natural language understanding. You can try other features like text chat with an expert, and we found that it had a very high abandonment rate. So then the next thing that you can go build is the offline diagnosis. And then the schedule an appointment. This also ended up being an extremely valuable feature where we saw 65% completion. So we can think about finding doctors as the next step for that. So again, like without investing a lot in ML and what you think in natural language understanding and natural language dialogue, you can get part of the way there if you think incrementally as a product manager and use lean principles to to incrementally design and build your solution as well. Yeah, so to sum up, as we started talking about the data science and the machine learning process, and within that, the product manager plays a really important role from acquiring data, from defining exactly what the goals are and what the targets are that your system needs to hit, to then collaborating with data scientists, communicating with your key stakeholders, iterating through the design and the evaluation phases of it, and then determining the delivery, like how we deliver the solution.